course. All right, so we were differentiating last time, which means, of course, now comes the integration. We are integrating our exponentials. These are the formulas that are on your formula sheet, okay? So you've got, as long as the derivative of the exponential is in front, then it just integrates to whatever the exponential part was, okay? It's not really practical though, most of the time, because how many times do you always have that perfect number in front of your exponential already? So, while you do have those formulas, me personally, this is how I think. So, let's first of all remember differentiating. If I had e to the power of 2x, when you differentiate it, it becomes 2e to the 2x. Okay? Let's take e to the 2x and now integrate it. Yeah, I'm starting with the same thing each time. So I'm going to start with the same thing each time. Because if I did start with the 2e to the 2x, go back to that when you integrate it. But what I'm saying is you don't always have that 2 that you need in front of your integral. So, if I just have e to the 2x, when you integrate it, you keep the e to the 2x, but remember that integrating and differentiating are opposites of each other. So when you're differentiating, you multiply the 2. When you're differentiating, what do you think you do? Divide it. It just all goes over 2, and then of course you'll have your plus c if it's an indefinite integral. Okay, so I think that's an easier process to do than to try and get that number in the front. So that's what this is, this version here. So here is another version that is useful, but not included. If you're integrating e to the f of x, it's e to the f of x over the derivative on the bottom. You see. Okay, so here we go. Question number 1. Integrating 2e to the 4x plus 5. So I'm going to ignore the 2 that is out the front, and I'm going to do my integrating with that e to the 4x plus 5, which is going to stay the same. I just have to put it over the derivative, which is the 4. Okay, and of course plus a c. Then there is a little bit of simplifying here that can happen. 2 over 4 just becomes a half. So you could write half out the front if that's nicer. E to the power of 4x plus 5 plus c on the end. Does that make sense? Try the next one. 3. We've got 3 different terms here. These first 2, they're normal things to integrate, and here's my exponential on the end. So integrating 3, what do you get? You just add, not differentiate, integrate. We want to add an x to it, so 3x. Okay? Integrating the minus 2x. You add 1 to the power, divide by the power. And then the exponential one, e to the 2x, all I have to do is divide by the derivative of the power, which is 2 plus c. So these 2's will cancel off, and you can tidy it a little bit. So minus x squared. Whoops, lots of weird lines there happening. Let's get rid of those. And then plus e to the 2x over 2 plus c. Okay, those ones are indefinite integrals because we have the plus c's. Then in question 2, we have the definite integrals because we have numbers on our integral sign. So let's do these ones. These go into square brackets, and we integrate the e to the 3x by dividing it by 3. Close the square bracket and put a 0 and a 2 on the end. Then your indefinite integral, we sub the 2 in first. Sorry, did I say indefinite? Definite integral. E to the 3 times 2, which is 6, over 3 minus, sub the 0 in. E to the 3 times 0 is 0 over 3. E to the power of 0 is 1, so I could just make that a little bit nicer by changing that to a 1 over 3. I'm happy with that answer, but you may also see in some work solutions that because you've got this factor of 3 on the bottom, you could put them together and get a common denominator, or you could even factorize the third out the front. They're all the exact same thing, different ways of writing it. Question B. Again, it's a definite integral, so open up your square brackets. Integrating the exponential, we keep the e to the 4 minus 3x, and we divide by what? Negative 3, good. Okay, on the end of my square brackets, we put a 3 and a 4, and now we sub in. E to the power of 4 minus 3 times 4, all over negative 3, minus e to the power of 4 minus 3 times 3, all over minus 3. 3 times 4 is 12. 4 minus 12 is negative 8. So that first one is e to the negative 8 over negative 3, but I might want to move my negative out the front. With the next one, these two minus signs, you bring this one out, makes a plus. So we have plus e to the 4 minus 9, which is negative 5, over 3. So again, we could do the different options. If we wanted to, we could get a common denominator, or let's just factorize the third out. I would probably even switch those around so that the negative one's in that second position, just to make it look a little bit nicer. All right, we happy with that? Yes, good. All right, over the page. Question 3. It is known that f dash x equals e to the x and f of 1 equals 0. Find the original function and then find f of 0. I'm giving you the derivative, which means if I want to find f of x, it's not saying it, but I have to integrate. So I'm going back from the derivative. So I have to integrate the e to the x with respect to x. Now, the integral of e to the x is e to the x, technically over 1 if we're doing our thing, but that's just the same thing, right? Plus c. Sorry, coughing. All right, then we're given some information to work out what the c is. We are told that f of 1 equals 0. So I'm going to sub that in. Sub f of 1 equals 0. Now this thing here is basically my y equals e to the x plus c, right? Y equals that, or f of x, sorry, equals that, because I've integrated the f dash x. So it will be 0 equals e to the 1 plus c. Get the c by itself, move the e to the other side, means c equals negative e to the 1. If I don't put the 1 there, it's assumed that it's there, right? You don't have to write that little power of 1. This means my equation for f of x is, if I follow here, e to the x plus c, it's e to the x plus, and I just found out that c was minus e. So it's e to the x minus e. There's one more bit. I have done the integrating, I've subbed that in, but now it says, then find f of 0. So now that I finally have the f of x, I want to find what f of 0 is by subbing the 0 in for where the x is. So e to the 0 minus e e to the 0 is 1, so it's 1 minus e. We still good? Yeah? Great. Question 4. If y dash equals 1 plus 2 e to the negative x, and y of 0 equals 1, find y and hence y of 2. That's pretty much just like the last question that we did, except we're calling it y of 0 instead of f of stuff, right? Very, very similar question. So to find the y equation, I'm going to have to integrate, that was a really cool integral sign, let's try that again. Integrate 1 plus 2e to the negative x with respect to x. Okay, integrating 1, I get x, don't differentiate, Grace. Integrating the 2e to the negative x. You go 2e to the negative x, what else? Over negative 1. The derivative of the x up here. Negative 1, it's up there. Okay? Then plus the c. Alright, so that's just x minus 2e to the negative x plus c. Yeah? Okay, we're part of the way. We have found our equation for y. Next part. Y of 0 equals 1. So I'm going to sub that in so I can find my constant. Okay? Sub y of 0 equals 1. So that means x is 0, y is 1. 1 equals 0 minus 2e to the minus 0 plus c. Okay? This is 0, obviously. E to the 0 is 1. So those things together there are negative 2. So I have 1 minus 2 plus c. Okay, move the minus 2 across the other side. C equals 3. Wonderful. My equation for y is now complete. It is x minus 2e to the negative x. And instead of the c, I now know that c is equal to 3. Still not done because hence find y of 2. So finally it wants me to now sub 2 into my equation. 2 minus 2e to the minus 2 plus 3. We don't want to go to decimals unless we have to, right? So this part's going to stay. But we're just going to go 2 plus 3 is 5. So we'll go 5 minus 2e to the negative 2. So if possible, leave your answers exact unless you need the decimal for something else. Okay, question 5. Find the derivative. Don't mix them up. I'm not looking at you. Okay. Find the derivative of y equals e to the x squared. We're going back to last lesson. How do we differentiate an exponential? The derivative of the power comes to the front and then the exponential stays the same. This one just looks a little bit weird because it's an x squared. But what's the derivative of an x squared? 2x. So 2x comes down to the front. Then I have e to the x squared that stays. Okay? Part B, hence. And when you see the word hence, it means that you're meant to use what you've just discovered to help you do this next part. Okay? Remember that integrating and differentiating are opposites of each other. So, if I now want to integrate 2xe to the x squared, which, to be perfectly honest, if I didn't have this, would be a bit of a pain in the butt because it's not just a normal exponential, it's like a product thingy happening in here. We don't even have a product rule for integrating, so yuck. Okay? So, luckily, that is exactly the same as that. So if I integrate the derivative, what does it do? It goes back to this one at the very, very top. Okay? So I don't have to use the formulas. I'll just say that integral is going to go back to e to the x squared. Now it's in square brackets because it's a definite integral between 1 and -1. Stub in e to the 1 squared, which is 1, minus e to the -1 squared, which is +1, that equals 0. Why is this result obvious without any calculation? Was it obvious? Or was it? Come on, you'll explain to me, Kieran. Correct. Maybe some more mathematical terminology in there? No? Oh, so close. Odd. It's an odd function. So it's symmetrical around the y-axis, which means the two areas are cancelling each other out, which is why it comes down to 0. Okay, so I'm going to write down 2x e to the x squared is an odd function and is symmetrical in the y-axis. Symmetrical, maybe that should be a bit better. Symmetrical, but one part above and one part below, right? So, therefore, the integral is 0. All right, part 6. Find the integral of e to the 2x over 1 minus e to the 2x in brackets all cubed. That's not a nice one. Okay, so do you remember the reverse chain rule? No, absolutely not. Well, let's have a little revision with our exponentials. Reverse chain rule is if we can get the derivative of the bottom on the top. So we start by saying whatever thing we have on the bottom, I'm going to call the u. So it's going to be u equals 1 minus e to the 2x, not the power of 3 part, okay? Just the part that's in the bracket. If I differentiate, u dash is equal to, the 1 will disappear, the minus will be there, the 2 will come down the front, e to the 2x. Okay, so if I can write my integral where I have the derivative of that bracket on the top, then I can use my reverse chain rule. So here it goes. I have fraction with 1 minus e to the 2x cubed on the bottom there. I need the top to be the u dash, which is the minus 2e to the 2x. I have changed the question, but it's close. Okay, I had the e to the 2x, e to the 2x. The only thing I've added is that minus 2 in there. So how do I compensate for timesing that minus 2 in there to make it the same as the original question? I times by -1/2 out the front. Now that integral is the same as the original question, but I can do my reverse chain rule, which is, actually before I do, I'm going to bring the bottom up before I do. So let's rewrite that one more time. So it's going to be minus 2e to the 2x. I'm going to bring the bracket up because I need that minus 3 up here, dx. Okay, cos. Now, -1/2 will stay. This part, because that is the derivative, it's kind of going to disappear now. So I just had the right thing there, so I'm good, it can disappear. This bracket, I'm going to add 1 to the power and divide by the power. So it becomes 1 minus e to the 2x to the power of negative 2 over negative 2. That's times with that minus half that's out the front there. And we plus the c. Just want to times these fractions together and put it back to be a positive power on this bracket. So on the top, the only thing I'm going to have is a 1. I don't even need a minus because those two minuses are going to cancel each other out. So it'll just be 1 on the top. 2 times 2 is 4 on the bottom. This whole bracket has a negative power of 2, so move it to the bottom, and it'll be 1 minus e to the 2x, all in brackets squared, with a plus c on the end. Do you remember reverse chain rule now? Oh, just that 2 times that 2. Because they're both on the bottom. Yeah. 2 times 2x. Yeah? All right, that's it, 6D. There's quite a good lot of questions in